अच्छा यार, CRO full form being cathode ray oscilloscope. ठीक है, it's tube, a confined tube which has a heater at one end and a screen onto the other end. In between, there is a metallic filament. The metallic filament is considered as the cathode simply because it is connected to the negative terminal, right? Whereas there are some anode plates and they are made anode by connecting it to the positive terminal of the battery. Initially I will switch on the heater, right? The heater makes sure that the heat provided to the metallic filament is sufficient enough to cause the emission of electrons from the metal surface. Metals are species that have delocalized electrons, right? So when the heat is provided, the electrons will be emitted from the surface of the metallic filament or the metallic plate. This process is called thermionic emission. Moving forward, as soon as the electron is emitted from the surface of the metal, right, the positive plate will attract it, right? And then there are Y plates, that is the plates being at the top and the bottom. These Y plates are responsible for the movement of the electrons in this direction, or let's say in this direction, right? Please understand that when the electron is emitted, they will have a range of kinetic energies. These electrons, once they strike the screen, right, they will convert their kinetic energy into light energy. Does that make sense? Does that make sense to you all? The entire tube is vacuum simply because of the fact that once the air molecules enter this tube, they will start colliding with the electrons, and that basically disturbs the entire process, right? A cathode ray oscilloscope somewhat looks like this, and please understand that the screen could look somewhat like this. Let's say for a minute that I connected my CRO, that is the Y input, right? I've just started it off. I've just switched on the CRO, right? There is no connections. There are no connections to it. I've just switched on the CRO. There would be no connection to the Y plate, therefore a dot, right? The Y plate is sensible for the movement in the upward or downward direction. So as soon as I connect the Y input terminals, there would be a translation of this dot in the upward axis or the downward axis, depending on what the value of the Y input is. This was the case with a DC supply, right? A dot appears when in case of a DC supply, and if the Y input is connected to an AC supply, you will see a vertical line, right? The reason behind all of this is a DC supply is a straight line, whereas an AC supply is somewhat like this. If I were to, let's say, rotate this screen if I were to rotate the screen and view from, let's say, this side, don't you think you would notice somewhat a line like this? That is why it's in the upward and downward direction. Basically, in easier terminologies, when there are no X plates connected, when there are no X axis values connected, you could say the screen would only show the Y translations. That is the upward or downward translations. As a matter of fact, the CRO is used to distinguish between an AC supply and a DC supply. DC supply meaning direct current, AC supply meaning alternate current. You can see the difference in the result, right? So simply the working of a CRO is based on the principle known as thermionic emission. Thermionic emission is basically when I am providing sufficient heat to a metal filament, it tends to lose its electrons. That is the emission of electrons from the surface of a metallic filament by supplying heat energy. These electrons are made to accelerate by an anode by connecting the anode with positive terminals of the battery. Right. Similarly, this acceleration allows the electrons to gain kinetic energy, and upon striking the screen, the kinetic energy converts into light energy. All of that we just discussed. It's everything, every single thing is written here. There is vacuum or air at a very low pressure to minimize the loss in kinetic energy. Had there been any air molecules that entered the tube, the entire functioning of the tube would be disturbed because air molecules would start to collide with the electrons. Right beside the anode, there are two metal plates known as the Y plates. The Y plates are responsible for making the electrons move vertically. CRO can be used to help you distinguish between an AC supply and a DC supply, and the CRO can also be used to help calculate unknown voltages of batteries. The exact procedure of it is as follows: that you initially connect the battery with the Y input terminals of the CRO. You set up the Y sensitivity or Y gain. Now, Y sensitivity or Y gain is a knob value, right? This will tell you, this will give you an estimate about the jump of the wave upwards or downwards on the screen. So you will simply set up the Y sensitivity or the Y gain value to any suitable number, and you will observe the jump on the screen. And you multiply the Y sensitivity value with the jump to obtain the actual voltage value. Let's say your Y sensitivity was at 4 volts per centimeter. This is called 4 volts per centimeter. Or you could say in that case, it's 2 volt per centimeter, let's say. It's on 2 volts per centimeter, right? In this case, starting of the CRO, it took up 4 blocks. So from here, you can work off that each centimeter is equals to 2 volts. So 4 centimeter would simply mean X, and you cross multiply, you get a value of 8 volts for this specific example. One major thing you need to understand is that the CRO value is limited. The screen value is limited. So let's say I have to measure off 8 volts. Let's say for a minute you have to measure off 8 volts. Right? if I am increasing my Y sensitivity, right, this jump, this jump would decrease, because putting it towards 8, let's say I am switching it such that, or let's say I am switching my CRO, now increasing the Y sensitivity value to 4 volts per centimeter. It has to cover off that 8 voltage value, but don't you think it will now only cover 2 boxes? My point from here is, if I am increasing my Y sensitivity value, the jump will decrease, simply because it now has a greater value per centimeter, right? And that's why it tends to give a larger value for small boxes. Like for 1 centimeter, if I'm shifting it to 4, that would mean that 1 centimeter now represents 4 volts. So it would need only 2 boxes to tell you that voltage value. Simply, my point is explained here. If the Y sensitivity value, is increased, the height of the jump will decrease. Similarly, if the Y sensitivity is decreased, the height of the jump will increase. And sometimes it is even possible that the spot completely disappears from the screen. Let's say you are increasing the Y sensitivity value to a very large number. You had to measure of, let's say, just 1 volt, and you kept on increasing the Y sensitivity value to, let's say, 100 volts per centimeter. You might not even see a spot on the screen, because 100 volt per centimeter would simply mean that a minute part of it would, let's say, if this is 100 volt per centimeter box, a minute part of it would represent 1 volt. So moving forward, right next to the Y plates, there are 2 more metal plates which are known as the X plates, shown in the diagram. These X plates are responsible for making the spot move horizontally or sideways. So X sensitivity or X gain or the time-based supply, all of these 3 names mean the same single thing, right? And just like the Y sensitivity, the X plate works in the exact same manner. Your question is, explain 3 changes that must be made to improve the shape of the graph. This is initially the graphical value. You could adjust the Y shift such that if you play around with the Y sensitivity value, the jump would either increase, this one. Let's say I am increasing the value, the jump would increase or decrease depending on its voltage value until it is at the center. If I am decreasing my Y sensitivity, the height would increase. And if I'm decreasing my X sensitivity, the width would increase, somewhat like this. Let's have another question. Show that the CRO must be connected, show that the resistor must be connected to a CRO. Simply, you took the positive part of the CRO and connected it to the area which was connected to the positive part of the battery. And similarly, the negative area was connected to the negative part of the battery, right? Now that you are opening the switch is open, as in There is no voltage value. The battery is not working. The X plates are off. When the switch is open, meaning to say your Y plates are also off. So you see just a spot on the screen. As soon as you are opening your X plates, meaning to say X, you are connecting the X plates of the CRO to this circuit, you see a translation on the x-axis. And as soon as your X plates are off, your switch is closed, meaning to say your circuit is now working. There is a voltage value now. You see a jump from the original point to a higher value, simply telling you that a voltage value has been obtained. Now that your switch is closed, meaning to say your Y plates are on, your X plates are also on. Simply you see a translation on the x-axis for that same dot. For an AC supply, if the X plates are off, meaning to say no translation in the x-axis, only Y plates are on, there's a vertical line. But when the X plates are also on, it will give you a certain structure. And in hospitals and all, for patients connected to the CRO, they have a heartbeat like somewhat like this. Moving forward, let's say my Y sensitivity is connected. My X sensitivity is also, my X plates are initially off, let's say. Explain what is observed on the screen when the sliding contact is placed at A. At point A, there is no voltage drop. This is a potential divider circuit. As soon as this potential divider moves till point B, the entire voltage value is dropped across the resistor, right? So when the X plates are off and it's at point A, there is no voltage drop. Voltage drop is equals to 0. So it's a simple dot value that you would see on the CRO screen. But as soon as the X plates are on, there's a horizontal x-axis translation. Similarly, when the sliding contact is slowly moved from A to B, as I told you, that the voltage drop at point B now would be the battery value. Let's say if the battery was 9 volts, all of those 9 volts will be dropped onto the resistors, given that there is no other component in the circuit. So when the X plates are off, you see a jump. When the X plates are on, you see a horizontal line. And let's say explain what is observed. The Y sensitivity is doubled. Doubling the Y sensitivity or increasing the Y sensitivity would decrease its jump value. We start off with waves. Now you need to understand that waves can be divided into two broad categories. There are progressive waves. Progressive waves basically can travel. There is a stationary wave. Basically, stationary waves do not travel, or you could say their energy is confined in a loop. Progressive waves can be divided into two broad categories. One is your transverse wave, one is your longitudinal wave. Transverse wave looks somewhat like this, whereas a longitudinal wave looks somewhat like this. Right? You need to understand that the wave particle, by the way, waves are energy carriers, and the energy is produced by the disturbances that they create. That is, the particles will vibrate. So if the wave motion is towards the right, the wave particle moves up and down. Meaning to say, the wave particle, the vibration of the wave particle and the wave motion would be perpendicular to one another for a transverse wave. Whereas for a longitudinal wave, the wave motion and the particle vibration would be parallel to one another. These are the waves, electromagnetic waves, water waves, etc. These are the sound waves, on a spring. Right? One more thing, transverse waves will constitute, transverse wave will have crests and troughs, whereas a longitudinal wave will have compressions and rarefactions. Compressions are regions of high pressure. Rarefactions are regions of low pressure. Let's say if I have a wave, this becomes its crest, this becomes its trough. Basically the maximum amplitude. By the way, amplitude is the maximum displacement from the mean position. So amplitude can be in the positive or the negative axis. Both are amplitude A.